Welcome back. In today's video, we'll be seeing the hands-on session for linear regression using Knime. So here we'll be predicting the mileage of the different types of cars. And the data set that we used in our previous data pre-processing session is will be used here as well. So the first step is always to do some data pre-processing, which is already covered in the previous video. I'll share the link in the description. You can watch once again if you would like to. So we'll move on from the data pre-processing to the next steps to do the linear regression. So if I have to recap on what we did as part of the linear data pre-processing, we had our cars mileage data details in one CVS file, and the origin of the car make is there in a different table. We have combined both the tables using joiner and then removed the redundant columns using the column filter. And then using the data explorer, we have identified the missing values and then have done the treatment to the missing values. So we have the complete data set, and we have converted the categorical variable into the numerical variable. So now if we see our data set is looking like this. So now that we'll be moving into the linear regression, so one of the fundamental rule for linear regression is that in the data set have to be independent of each other. Okay, so but then if we see here, after the one-to-many conversion of the categorical variable origin name into its binary representation, we see that now there is a high correlation between the origin name and this numerical values here. So we know now there is redundancy here that has to be removed. To remove again this redundancy in the data, because now this data will be passed to the linear regression model training, we will remove the redundant columns before passing it on to the linear regression. So for that, again, I will use the column filter, correct the sorts, and we will be using the origin name is excluded because these three of the variables are representing the origin name, so that is redundant. Now again, even these three variables, if you go back to the data set, one variable from this. So I'm removing Asia from the data set. So now we have removed the origin name and Asia, because if America and Europe are 0, 0, and then it is obvious that Asia is 1. Okay, now this becomes the origin name, and one of the numerical in this becomes the redundant variables. Now this is going to be our final date in the columns, that the features that we are going to use it for the linear regression. Okay, now this is how our data set looks again with the 10 columns, origin name removed, and also the Asia column has been removed. I'll create an annotation. Okay, now this is all our part of data pre-processing. Okay, now let us see how do we do our linear regression now. So for that, the first thing is that now our the final table, the number of columns that are features that we are going to pass to the regression model is available here, and then now this has got 398 records. So always for a any machine learning model, we actually split the data into training and testing. Okay, so for that, let us partition the data into our 70/30 or 80/20 data sets. So I'm using a partitioner node. I want to connect the data source, okay, and then execute. Now you see the table has been already by default, it's already here. Okay, now we have already seen that the relevant size of the table is already set to 70. So now this table is, now our whole of the data set is being split into two sets, the first partition with 275 rows and the second partition with 120. So it has done a 70-30 partition. Step is to train the model, train the linear regression model. Okay, for that we need to pull in the linear regression node. So for this we have the linear regression learner node, which will help you to train your model. So for that, as an input source, I am giving the first partition, which is the training data. And then I will have to configure saying what is my target variable. In this case, I'm going to predict the mileage per gallon, and rest of the items in the table are going to be my features or independent variables. So I want to use all of them. So they will remain as is. I execute, and then now the linear regression model has been executed, and it has calculated the coefficients which will be used for the linear regression. Now the model has been trained. Now the next step is to see how good is the model has learned, and to see that with help of a predictor. For that I will use a predictor. So I'm using a regression predictor to predict the, to see how good the model has learned. As an input source, I will connect the machine learning, the input from the regression learner, and because I want to predict all the my test data, I will use the test data as the source, and then configure. Yeah, my target variable is, it's going to create a new prediction miles per gallon as a new column, which will help us to see how the prediction values are, and then now we will execute this node. Okay, now as you see, now this is my target variable, miles per gallon. This is the data that is available in the test data set, and it has also predicted what will be the potential prediction of miles per gallon with this new prediction field. But like no, we want to see how good is this prediction. For that, we need to see the accuracy of the model. So that will be done with help of a numerical scorer. Now this will help me to see how good the my model has been trained, and then how well the model is predicting on a futuristic data. So I'll connect my data source and then configure. What is my reference column? I want to check the validity of the miles per gallon with respect to the predictor column prediction MPG. So this is where I want to check how the, what is my reference data with the miles per gallon that is already available in the test data, and how the my prediction algorithm, how the machine learning algorithm has predicted this value as per the model it has been trained on. I will apply and then execute. Okay, now we will be able to see the output. So this is how the linear regression metrics are looking like. The R square and absolute R square will give you how the accurate the model is, and the mean absolute error, mean square error, and the root mean square error will tell you what is the error in, like no, how much is the deviation. So R square, generally higher R square and adjusted R square, the higher the better. Obviously, the absolute error can be as low as possible. So if want to increase the performance of the model, there is one possibility that you increase the number of independent variables that you are training your model on. So there is a probability that you can increase the R square by adding more independent features to the algorithm. But then you also have to take into consideration that what is the adjusted R square, because not every time, like if you increase the number of variables, the performance of the model may not increase. So that is why it is always good to see how the R square and the adjusted R square are mapping to. If both of them are increasing, then it is a good addition of new variables to make the prediction much better. So as we have seen, this is how using Knime we can do the linear regression. and we can see the accuracy of the model with respect to the metrics that are given from the numeric scorer. So if we have to summarize, first we have taken the data source or raw data source from two different CVS files, done some kind of pre-processing to ensure that we provide the right details to the linear regression model. And then we have used a table partitioner to partition the data into 70-30 set, and then we pass the training data set to the linear regression model so that the machine will learn from the training data. Now to see how the model has been trained, we use the test data to see the prediction values. That is where we use the regression predictor. And now to see the accuracy of this whole linear regression model with our training and then testing, we have used the numeric scorer to check the accuracy of the model. As per the accuracy, as per the metrics that are provided from the R square and adjusted R square and the mean absolute error, we are able to see that this is a good prediction model, and this is how linear regression is done using Knime. Thank you for watching.